Natural forces continually reshape the Earth's landscapes. Volcanic eruptions, lava flows, earthquakes, rivers, and waterfalls contribute not only to the beauty of our world, but the destruction of it as well. Slowly but surely, quickly and dramatically, the Earth is changing. Here, on this dynamic planet, there is much to discover about the forces that shape the Earth. What is it like below the surface of the Earth? Based on data derived from seismic testing, geologists recognize that the Earth's interior consists of different layers, composed of materials having different properties. The crust, often identified as the outermost layer, is rigid and very thin. The mantle is dense and is made up of a hot layer of semi-solid rock. The core is made up of two distinct parts, a liquid outer core and a solid inner core. Within the Earth, there are two sources of heat, radioactive decay and residual heat. Part of the planet's composition contains radioactive elements such as uranium, thorium, and potassium. These radioactive elements decay naturally and release energy as they lose particles from their nuclei. This energy is released in the form of heat and travels outward, slowly migrating toward the Earth's surface. The other source of heat, residual heat, is the gravitational heat left over from the formation of the Earth when the cosmic gases and dust were compressed. What are the lithosphere and the asthenosphere? The outer rigid unit of the Earth covers the entire surface of the Earth and consists of the uppermost mantle and crust. The upper part of the mantle is cooler and more rigid than the deep mantle and in many ways acts like the overlying crust. This rigid unit of rock is identified as the lithosphere. The lithosphere tends to be thinnest under the oceans and in volcanically active continental areas such as the western United States. The average thickness of the lithosphere is measured approximately 50 miles or 80 kilometers. Scientists believe that below the lithosphere there is a relatively narrow, mobile zone in the mantle called the asthenosphere. This zone is composed of hot, semi-solid material, which can often soften and flow after being subjected to high temperatures and pressure over geologic time. The rigid lithosphere is thought to float or move about on the slowly flowing asthenosphere. With the discovery of the asthenosphere, geologists are better able to explain the theory of plate tectonics. What is plate tectonics? According to the plate tectonics model, the lithosphere is broken into plates. There are 7 large and many small moving plates. The 7 large plates are the Pacific, North American, South American, African, Eurasian, Australian, and Antarctic. The largest is the Pacific Plate. The unequal distribution of heat within the Earth and the weak nature of the asthenosphere's hot, gradually deformable layer of rock facilitate the motion of the lithosphere. The average rates of lithospheric plate separation can range widely. In what ways do the major plates move? Under the ocean basins, molten rock may well up between separating plates to form new ocean floor. Here, pillow basalts, which are bud-like rounded lava rocks about the size and shape of a pillow, are caused by the extrusion of this molten rock directly into cold ocean water. As the plates move away from each other, the fractures created are immediately filled with molten rock that has oozed up from the hot asthenosphere. Most upwelling of material from the mantle along separating plate boundaries is mostly found underneath the Earth's oceans. The upwelling area is recognized as the mid-ocean or mid-oceanic ridge. This region, where the rigid plates are moving apart, is identified as a divergent boundary. When the ocean plates move away from each other, they may at the same time be sliding under the continental plates. As the two plates converge, the leading edge of one is bent downward, allowing it to descend beneath the other. As the plates descend into the earth, it is absorbed into the mantle. The region where the lithospheric plate descends beneath the overriding plate is identified as a convergent boundary. How does plate movement generate earthquakes? Along mid-ocean ridges where the plates separate, there is a continuous pattern of shallow earthquakes. Earthquakes also occur along the boundaries between colliding plates. Over 3/4 of the world's earthquakes take place at convergent boundaries. As the plates move, the rock deforms and stores energy. Earthquakes occur where this pressure on the rock builds up to a point, breaks, then rapidly releases the energy. An earthquake is the vibration of the earth produced by this rapid release of energy. These vibrations are known as seismic waves, and they radiate in all directions from its source. When a large earthquake occurs near a major population center, its energy may be among the most destructive natural forces on Earth. Along with earthquakes, a phenomenon known as liquefaction sometimes results. During liquefaction, some soils and other unconsolidated materials containing abundant water are turned into a fluid-like mass that is not capable of supporting buildings. The shaking of the ground, coupled with the liquefaction of some soils, may damage buildings, bridges, and other structures. Also, when a quake takes place in a developed area, water mains break, causing the loss of available drinking water. Power and gas lines rupture, causing numerous fires. How does plate movement generate volcanoes? Most volcanoes are usually found where two of the Earth's plates meet. When the oceanic plate and the continental plate move together, the oceanic lithosphere is consumed into the mantle. As the plate sinks down, it heats up and partial melting develops, generating magma from below. As the molten rock becomes hot and less dense than the surrounding mantle, the magma rises, melting other rocks. The blobs of magma eventually migrate to the surface, giving rise to volcanic eruptions. As the lava pours onto the earth from a central vent, large amounts of lava and ash accumulate, resulting in the building up of mountains. Mount Rainier, Mount Baker, and Mount St. Helens are volcanoes that have contributed to the building of the Cascade Mountain Range in the western section of North America. What is the rock cycle? The crystallization, weathering, erosion, deposition, lithification, and metamorphism of the rock constitute a continuing rock cycle. It is important to note that the total amount of material stays the same as its forms change. After weathering, along with erosion and deposition, comes lithification, the process by which sediments are transformed into solid sedimentary rock. The processes of metamorphism form metamorphic rock. When metamorphic rock melts and returns back to the earth as magma, the cycle is completed. There are 3 rock types: igneous, sedimentary, and metamorphic. How are igneous rocks formed? All rocks are originally formed from the molten material found within the earth, called magma. Either beneath the surface or following a volcanic eruption, the magma cools and solidifies. This process is called crystallization. When magma crystallizes, it forms igneous rock. The kind of igneous rock which results is determined by the rate at which the magma cools, the composition of the magma, and the amount of dissolved gases in the magma. When magma rises to the surface, it loses many of its gases and is renamed as lava. When lava solidifies, it is identified as an extrusive rock. As lava is exposed to the Earth's atmosphere, it quickly cools and doesn't have time to form large grains or crystals. This black basalt is an example of a flow of lava that cooled rapidly into an extrusive igneous rock. The porous nature of this extrusive rock, called pumice, is due to the steam and other gases that quickly escaped it. Magma that remains below the Earth's surface cools slower than the magma above the surface, resulting in the formation of rocks such as granite. These rocks exhibit characteristics of large mineral grains in a slightly rough texture. Igneous rocks that are formed by the cooling of magma below the surface are called intrusive rocks. A large mass of magma located far below the surface may require tens of thousands, even millions of years to crystallize. Most mountain ranges and much of the continents are made up mostly of intrusive rocks. Through forces within the Earth and outside the Earth, large masses of intrusive igneous rocks are uplifted and exposed. When igneous rocks are exposed to the atmosphere, weathering often takes place. There are two kinds of weathering: mechanical and chemical. What is mechanical weathering? Mechanical weathering is the process by which a rock is broken into smaller pieces, with each piece retaining the characteristics of the original rock. One of the most common forms of weathering is frost wedging. Frost wedging happens when the water penetrates into the cracks of a rock, freezes, expands, enlarges the opening, and breaks the rock. Water expands to 109% of its original volume when it freezes. This force breaks rocks apart. After many freeze-thaw cycles, the largest of boulders are broken down into the smallest of rocks. Biological activities such as plant roots cracking rocks also contribute to the breaking down of rock. In search of water, the roots of trees and shrubs are constantly growing into the rock's fractures. As the roots grow further into the crack, they slowly force the rock to break apart. What is chemical weathering? Rocks are made of a consolidated mixture of minerals. Chemical weathering is the process that breaks down rock. This process alters the internal structure of the rock's minerals by adding or removing elements. One example of chemical weathering is oxidation. The same oxidizing forces that rust nails and car bodies also break down rock formations. The iron within these rocks has oxidized and exhibits a reddish-brown color. The formation of underground caves is another example of chemical weathering. When carbon dioxide in the atmosphere and in the soil collects in water, it transforms the water into carbonic acid. When carbonic acid percolates down into large underground limestone deposits, spectacular caves result. Here we see the result of carbonic acid carving these caves and the deposition of calcium carbonate into formations of stalactites and stalagmites. What is erosion? Erosion is the wearing away of any part of the Earth's surface by natural agencies. These include the action of waves, wind, glaciers, streams, and rivers. During erosion, the rock and soil are removed and transported to a new location where they are deposited. The deposited rock is referred to as sediment. How do glaciers shape the Earth? Glaciers are made up of fallen snow that over many years compresses into large thickened ice masses. Glaciers form when snow remains in one location long enough to transform into ice. What makes glaciers unique is their ability to move. Due to sheer mass, glaciers flow like very slow rivers. Some glaciers are as small as football fields, while others grow to be over 60 miles or over 100 kilometers long. Glaciers not only transport materials as they move, but they also sculpt and carve away the land beneath them. A glacier's weight, combined with its gradual movement, can drastically reshape the landscape. The ice erodes the land surface and carries the broken rocks and soil debris far from their original places, resulting in some interesting glacial landforms. One of the most striking examples of a glaciated valley can be seen here in Yosemite National Park. Yosemite Valley gets its smooth U-shaped profile from the action of glaciers. Thousands of years ago, a glacier filled the entire valley. Gradually, the glacier retreated, creating sheared-away mountainsides in a deep valley with vertical walls. How does the force of streams and rivers shape the earth? Running water is the dominant agent for shaping much of the Earth's surface. The ability of a stream or river to remove rock and soil and transport these materials depends on two factors: the speed at which it is moving and its discharge. Water flows to the ocean under the influence of gravity. Therefore, the slope of a stream and the stream's discharge determines the speed at which a stream flows. Mountain rivers and streams usually flow more quickly than rivers in low-lying areas. The steeper the stream and river channel, the more stream flow energy is created. The discharge of a stream is the volume of water flowing past a certain point at a given unit of time. The discharge is usually measured in cubic feet per second or cubic meters per second. Large discharge rivers usually flow more rapidly. The amount of sediment and rocks that streams and rivers carry is referred to as the load-carrying capacity of the stream or river. The higher volume of water flowing in a stream, the greater the quantities of sediment carried in it. The load may be carried as solution, in suspension, or by moving slowly along the bottom. The muddy appearance of a river indicates that it is carrying a load of sediment in suspension. During flooding, the load-carrying capacity of rivers and streams often becomes hundreds of times greater. At times, a flooding river can erode and transport more sediment in a few hours than during several months of a normal flow. When a river slows down and enters the still waters of an ocean or lake, its ability to carry sediments decreases and starts dropping its load of sediment. When the Mississippi River hits the Gulf of Mexico, it slows down and deposits huge quantities of sediment as seen from this satellite picture. Here a delta is formed. The word delta comes from the Greek letter delta, a letter shaped like a triangle that is the same shape of most river deltas. The rocks and boulders that are scooted or rolled along the bottom are referred to as a bedload. As the rocks roll and grind against the riverbed and against each other, their sharp edges are worn down, eventually forming smooth-shaped rocks. These types of rocks are often identified as river rocks. Rapids and waterfalls are all visible signs of the river's powerful ability to break down and transport rock. Rapid mountain rivers usually drop down steep slopes and produce very deep, narrow gorges and V-shaped valleys. Once erosion has eliminated the resistant rock, the stream's downward slope decreases. As the river approaches sea level and the slope of its channel becomes nearly flat, the river's erosive force becomes more dominant on the banks of the river. When the slope is at a minimum and the banks continue to erode, the river tends to become much wider and flows more slowly. Here, the river's side-to-side cutting action into the landforms creates sweeping wide bends of flowing water called meanders. After the rock has been lifted, transported, and deposited, the next process of the rock cycle is lithification and the formation of sedimentary rocks. How are sedimentary rocks formed? The process of particles falling from suspension or being precipitated from solution to form layers of sediments is called deposition and takes place before lithification. Lithification occurs when the unconsolidated sediments are converted into solid rock. Lithification may involve a combination of such processes as compaction, cementation, and crystallization. After the sediments are deposited and compacted, dissolved minerals, pressure, and time cement the rock particles together. The new solid rock is identified as sedimentary rock. During the reformation of igneous rock into sedimentary rock, the total amount of the changed rock material stays the same. About 75% of rock outcrops on the continents are sedimentary. Sedimentary rock layers are often exposed throughout the canyonlands in the state of Arizona. Notice how the sedimentary rock formations are often stratified into distinctive layers of rock. By examining sedimentary rocks, one can trace the course of its origin. There are different types of sedimentary rocks. A conglomerate rock indicates the joining together of rounded stream-deposited gravel-sized rocks and pebbles. The fusing together of sand-sized grains identifies sandstone. Shale was formed from mud made of fine silt and clay, later giving the rock a nice smooth texture. Cementation is the process by which dissolved minerals cement or glue sediments together, providing sedimentary rocks with distinctive characteristics. When silica forms the cement, it produces the hardest sedimentary rock. Reddish and rust-colored sedimentary rock usually means iron is present. The metamorphism of rock follows the formation of igneous and sedimentary rocks. How are metamorphic rocks formed? Metamorphic rocks are formed from pre-existing rock deep within the earth by heat, pressure, and/or chemically active fluids, always maintaining its solid state. Throughout the metamorphic process, the total amount of the pre-existing rock material remains the same as its form changes. In extreme metamorphic environments, the temperatures may approach close to melting. However, the changed material must remain solid. Just as this cube of butter is soft, yet still retains its solid nature. This process of rock transformation can change the existing rock size, shape, and texture. Here are several examples of this transformation of rock. Shale, after exposure to heat and pressure, becomes the metamorphic rock called slate. When limestone goes through the metamorphic process, it recrystallizes, forming the beautiful metamorphic soft rock called marble. When this igneous rock granite goes through the metamorphic process, it reforms into the rock gneiss. Recently, humans have attained the magnitude of a geological force, transforming about 40% of our planet's surface. Due to technical capabilities and a large population, human transformation of the land, water, and atmosphere has increased at a rate more rapid and at a scale more grand than our species has ever witnessed. The result has led to major consequences, such as toxic chemicals in the land and water, high concentrations of carbon dioxide in the atmosphere, and the loss of species and habitat. Hopefully, through research and an understanding of human-caused global change, we may better manage our transformation of the land and continue to benefit from our ever-changing and dynamic Earth. Number 1. The radioactive elements within the Earth decay naturally and release energy as they lose particles from their nuclei. Number 2. The rigid lithosphere is thought to float or move about on the slowly flowing asthenosphere. Number 3. Lithification is the wearing away of any part of the Earth's surface by natural agencies, such as waves, wind, and glaciers. Number 4. Weathering is the process by which a rock is broken into smaller pieces. Number 5. Igneous rock is formed from the crystallization of molten magma. Number 6. What is the name of the region where the rigid plates are moving apart? Number 7. What is the name of the boundary where the lithospheric plate descends beneath an overriding plate? Number 8. What is the name of the model that illustrates the origin of the 3 basic rock types? Number 9. What type of rock is formed by the alteration of pre-existing rock deep within the Earth by heat, pressure, and/or chemically active fluids? Number 10. During the process of the reformation of rock, what amount of pre-existing rock remains the same as its form changes?